Hello, and thanks for tuning in to the Biomass Magazine podcast series. I'm your host, Anna Simet, as part of our panel preview series. Today we have with us a company presenting at our upcoming International Biomass Conference and Expo. So our guest on this episode is Paul Dimick, General Manager at IntraMicron, Inc. Paul, how are you? Thanks for joining the podcast today, and welcome.
Thank you, Anna. I'm happy to be here and looking forward to discussing SourCat with you.
I am as well. So, Paul, you've been with IntraMicron since 2010. Why don't we start with you telling us a little bit about the company and what you do there?
Sure. So I joined IntraMicron in 2010 as a research and development engineer after I had completed a postdoc working on catalysis. IntraMicron itself was founded in 2001 to commercialize technology that was developed in Dr. Bruce Tattertuck's lab at Auburn University. And the core of that technology centers around microfibrous materials and their application to a variety of catalytic processes. So IntraMicron was founded then. Between 2007 and 2010, the focus of the company shifted to its own intellectual property development for a variety of different technologies centered on microfibrous materials, but also to solve other challenges in the energy and defense industries.
Okay, so you guys are presenting at the upcoming Biomass Conference and Expo in Richmond, Virginia in early March, and you're going to focus on your SourCat sulfur recovery system. Can you give us a rundown of that technology?
Sure. So how we started doing SourCat is actually a bit of an interesting story. With a lot of our microfibrous materials technology, we were doing a lot of work with synthetic fuels, and we've done a lot with Fischer-Tropsch synthesis and its application to a variety of scalable applications. Even recently, we did our first commercial Fischer-Tropsch catalyst. But when you look at scalable synthetic fuel production, one of the biggest challenges is cleaning up that gas. And because of the technical expertise of the team here, we focused a lot on scavenger-based technologies. And what we found was that scavengers themselves are often very expensive to implement, particularly as the amount of sulfur that you have in that stream gets higher. So whether you're dealing with a traditional biomass or you're dealing with waste from an ag digester going into an ag digester, typically what will happen is you'll wind up with these sulfur concentrations in the hundreds to thousands of parts per million. And the cost to remove that with a scavenger is more or less linear with the amount of sulfur that's present. So we thought, hey, can we develop a way to do this catalytically? Now, doing the process catalytically is something that's kind of been investigated since the early 70s. However, the challenge was the catalysts that were developed were not very selective towards elemental sulfur. So myself and Dr. Hong-Yoon Yang worked together to come up with a catalyst that we thought could take that hydrogen sulfide and selectively convert it into elemental sulfur. So we started that development in around 2012, 2013, and we got funding through the NSF SBIR program to develop that catalyst. And through that funding, we were able to basically demonstrate that this catalyst was capable of selectively converting hydrogen sulfide into elemental sulfur. And the way we do that's with partial oxidation. And what makes it very interesting compared to other processes is it's highly selective. So that allows us to add a very small amount of oxidizer into the stream and get very high selectivity to elemental sulfur. So we originally started with kind of RNG as our target application, but since then we've actually expanded to a variety of different feed streams where we can apply that catalyst and then the process. The process was obviously developed to demonstrate the catalyst at a variety of different scales and for different feed streams.
Really interesting. So the process has been validated at pilot scale, correct? Tell us more about that.
Yes. So we've actually done 3 distinct pilot demonstrations of this technology. The first one was actually up at EERC in Grand Forks, North Dakota. It was supported by DOE funding, where we're actually desulfurizing syngas that was created by gasifying coal and coal biomass blends. So that desulfurization of syngas is unbelievably challenging because not only do you have the presence of hydrogen sulfide, but also carbonyl sulfide. And in this situation, it was very difficult because after the gasifier, you get this syngas stream that's got tars and hot ash in it. We were able to desulfurize after the hot ash filter, and we demonstrated over 93% recovery in that syngas stream with unbelievable selectivity to elemental sulfur. So that was a resounding success, and that's primarily targeted at syngas applications. Now, for that demonstration, that was coupled with a Fischer-Tropsch demonstration. We actually showed that we could remove it down to ppb levels, because with our sour cat process, we'll commonly either use the catalytic step part by itself or the catalytic part of the process followed by a scavenger to bring it down to any level. The second demonstration was at a wellhead, 100,000 cubic feet a day in South Texas. So we actually were at a wellhead that was a gathering point of multiple wells. And that one, we actually demonstrated the ability to selectively remove hydrogen sulfide from that raw elemental gas from concentrations ranging from as low as 20 to 30 ppm up to 6,000 ppm. And the final one was recently in North Carolina at an RNG production site. So at that site, they were actually using a process to separate both CO2 and hydrogen sulfide from an RNG stream. And then we were desulfurizing that CO2 stream with the H2S in it. And that was an application that was really great because we could show that we could selectively remove very high concentrations of H2S. We were looking at around 7,500 ppm. And at points during the demonstration, we got recoveries up to 98% of elemental sulfur, which is really important because it was kind of fun when we were at the site, because when you were there before we were running, you could smell the SO2 and the flare. But then after we started running the process, that smell went completely away because we were recovering 98% of that hydrogen sulfide as elemental sulfur.
Very cool. So speaking of hydrogen sulfide, is meeting air permitting regulations a challenging aspect of RNG project development right now?
Certainly. So hydrogen sulfide is a really tough one because it presents both a safety concern as well as a permitting concern, because you can't, parts per million levels of hydrogen sulfide can actually kill you, which is pretty bad. So typically what has to happen is that hydrogen sulfide has to be dealt with. Commonly, if you have hydrogen sulfide in a stream that's going to, say, a pipeline, it has to be removed to below 4 parts per million. But if you're doing a separation up front, for air permitting requirements, you can't just release it, so you have to convert it to SO2. So commonly what will happen is they'll either use a scavenger to capture it, which is great in a lot of cases because it works really well. However, you get this kind of vicious cycle where oftentimes if that's a disposable scavenger, you'll have to take that scavenger and you'll have to put it in the landfill. And then when you generate landfill gas, that sulfur eventually end up back in that RNG coming from the landfill. Whereas with our case, we can actually recover that elemental sulfur from that CO2 H2S stream and take it and actually get a sulfur byproduct that we can use that can actually be added back onto the fields and used in a variety of other agricultural applications. So it's a great way to actually recover that sulfur and put it back into the soil where it can be used for valuable applications.
Very well explained. So, Paul, what do you think sets the sour cat system apart from others?
So I think the biggest distinguishing feature, and when we went to develop it, surrounds how simple the process is based on what it does. If you look at a lot of the catalytic processes to remove elemental sulfur, they either rely on bacteria, which can be temperamental, or they're multi-step processes. We have a single-step gas treatment process where we can selectively convert that hydrogen sulfide into elemental sulfur. And everyone we brought out to actually see the system in operation, they've commented on how simple and straightforward it is. And that's really one of the huge benefits to the process is we have this single step process. It's based on inorganic chemistry, so it's very straightforward. The catalyst has a long life. It's relatively easy to control. And it kind of provides this middle ground between the simplicity you get by a simple scavenger system, but the benefits you would get from a more complex multi-step catalytic system that's commonly used most of the time in the petrochemical industry. More often in the RNG space, biological systems are used. However, from a lot of the people that we've talked to, they can be awfully temperamental. And if you don't keep the bacteria happy and the solution chemistry happy, it can be a challenge. Whereas with ours, we're doing all the chemistry in the gas phase to actually convert that hydrogen sulfide and recover it as elemental sulfur. So it does provide a level of simplicity from that front.
Mm-hmm. Well, I sure look forward to the presentation at the upcoming conference. Before we wrap up, is there anything else that you would like to add about the presentation before we end?
Yeah, I think it's going to be a great presentation for anyone who's interested in the sour cat technology and looking for alternatives to some of the traditional approaches to sulfur recovery. Sulfur recovery is a tricky business, and it's one of the real challenges associated with a lot of these development processes because it's really a sunk cost. And one of the things that our system really provides is a level of flexibility in terms of the ability to operate over a very wide range of sulfur concentrations with a relatively constant cost in terms of an OPEX. So that's something that for a lot of operators, having that kind of low risk relative to how that OPEX is going to be as a function of the amount of sulfur in their feed is a really big deal. So hopefully we'll be able to provide everyone a good overview of the process and how it applies. And hopefully people will find it interesting. And, if all goes well, maybe we'll get the opportunity to demonstrate and install some upcoming projects.
Absolutely. Well, I want to thank you so much for coming onto the podcast and telling us more about IntraMicron and SourCat.
Great. Thank you for having me. I'm looking forward to hopefully attending the conference and sharing more about SourCat.
IntraMicron will be presenting at the International Biomass Conference and Expo in Richmond, Virginia on Tuesday, March 5th at 3 p.m. on panel titled Deploying Best-in-Class Treatment Technologies to Increase the Value of Produced Biogas. Register for or learn more about the conference at biomassconference.com. Biogas and RNG producers get in free. And that will conclude this episode of the Biomass Magazine podcast. Thanks for tuning in. Until next time.